Hello, everyone. Welcome back to another video from the lecture series of the programming implementation of various cybersecurity fundamental concepts. In this video, we are going to be looking into how to build our very own password cracker tutorial in Python. But before we begin the video, a quick disclaimer that all content in this tutorial that we are going to be looking into is for educational purposes only, right? So any part of this content must not be used in any way in an unethical fashion that may cause harm to any users or organizations in any form, financial or otherwise, right? So please keep in mind that the goal of this video is for educational purposes that reinforces our discussions that we had during the digital authentication chapter and the topics that we were covering within that in order to see how these attacks are actually carried out so we can better prepare ourselves to prevent these attacks and safeguard and put safeguards in place that can help provide protection to us. So to start off with the security logic, we are basically going to be doing basic password cracking, right? And as we had discussed during our lecture sessions, there are two significant ways in which the typical or the fundamental nature of password cracking can be implemented. So those are in the form of either using what we call as dictionary attacks, and the other method is basically the brute force attacks, right? So brute force attacks, as the name suggests, is the more, well, for a lack of a better terminology, the simple-minded attack, right? Where essentially the attacker is going to try out all possible combinations of a password that a user might have, which is stored within, let's say, a file or a database. And then, we try to predict, or the attacker's program or script tries to compute the actual password which is stored. And then, if it is successful, then they are able to get access to the system in an unauthorized way. And if it is not successful, well, that's the end of the story, right? And that takes time because given the fact that the nature of the brute force attack is to exhaustively search for all different possible combinations of characters that can constitute a password, it will essentially take a lot of time depending on the length of the password that you essentially have, right? So if you have 4 characters password, to take a simple example to kind of drive the discussion, then your program will go through all different possible combinations of characters that the hash of that 4 password or 4 character password will have, given the type of hash mechanism that you're using, and then try to find a match with the computed hash value of a particular password, right? Remember, we are not going to do plain text comparison here. It's not that if we have, let's say, an input or a saved password like S that is present in a file or a database, it's not that the program is trying to go through all possible combinations of a 4-letter password or a 4-character password and then test all different combinations of characters or alphabets that could be present in each of these different places, right? And then figure it out. But essentially, we will be using the notion or the idea that for security purposes, here we are only storing the hashes of our plain text password, right? So we will make it a little bit complicated. We will not, keep things way too simple. So we will still abide by the fact that we won't store plain text passwords in our files or our databases, but we will use hashes, but we are not considering any slow hash function for the sake of simplicity, and we are not considering the addition of salts to our hashes as well, right? So that kind of, once we look into this implementation, that kind of will make us appreciate even further the importance of slow hashes and the importance of salts in storing our digitized version of our passwords in the files and or databases, right? The other method of attack is basically using a dictionary attack, right? And there are variations of the dictionary attack where you have rainbow table attacks and stuff like that, right? But the whole idea here is that you already have a set of well-known passwords that people keep track of on the internet as well, right? If you do a Google search trying to find out the most commonly used passwords and stuff like that, there are projects on GitHub which keeps a track of that, and they continuously update those files by keeping a track of different types of commonly used passwords that user might have, right? Just to remind companies that if a user does select any one of those passwords, then you should notify them and prevent them from using that password, right? Although that is seldom implemented in many systems, which kind of leaves us vulnerable to these type of attacks, right? So that's something that you have to keep in mind. So once we do download that file or that dictionary, which contains a list of those different commonly used passwords, then what can be done is that given the password that we are trying to crack, which is basically a user's password, we do a pre-computation of all the hashes of the commonly used passwords that is present in this particular file, and then do a quick comparison or like a lookup operation, which takes a unit time, and then to see if there was a match of the user's password that you're trying to crack against any one of those commonly known passwords. So here, there are benefits, there are disadvantages in the sense that if the user's password is not present in the dictionary file, then you cannot essentially compute that particular, or you won't find a match or a hit to that particular user's stuff. So it is fast, but it also is limited to the amount of inputs that is present in the file that you're using as a reference to perform that dictionary attack, right? Whereas in brute force, you're not limited by the availability of known commonly used passwords, but at the expense of computational complexity is what you achieve that, right? You achieve that avoidance of that constraint at the expense of computational complexity, right? So those are basically the trade-off between the two attacks. One is faster, but has a constrained scope. The other one doesn't have a constrained scope, but you pay in terms of the resources that is required to run that attack and the amount of time that it will take depending on the length of the password that you're trying to break, right? So we will see how to implement both of these techniques. And of course, we will do it in a controlled narrow scope. So it's like in practicality, for example, like we discussed, passwords are not just stored as secure hashes, and we don't use fast hash functions in order to implement them. So even though through those assumptions, we will be able to understand how password cracking is work, you won't be able to use this in a realistic scenario, because as long as a company is following, or an organization, their implementation of security functionality requirements, they're following the standardized requirements that, for example, is set up by NIST, right? Then this will essentially not work, right? But it will still give us a good run for our money with respect to educational purposes. So that's a good exercise to perform, right? So our goal is to understand how it works, and essentially through that, how it can be prevented, and further appreciate the mechanisms that we have discussed in class on how they actually, help in scenarios like this, right? So as far as the program logic is concerned, we are not going to be using any kind of file, to store our passwords for different users or any kind of database server. So all we are going to do is we are going to replace that mechanism with first asking the user for an input, which will basically be, simulating the scenario that what if this was the password that was stored in the password file, or that was stored in the database table, which was having those different passwords, right? So that will be the first input that we will ask the user to provide us with. And then after the user provides us with that input, we will save it somewhere in some variable inside of our program. And then the next set of inputs that we will ask the user is basically we will provide the user with a menu, and that menu will be representative of the two different attack vectors that we are going to be implementing. So we'll ask the user that, hey, do you want to implement or use the brute force method, or do you want to use the dictionary method, right? So then the user will, let's say, these will be represented by two different numerical options. So let's say one for brute force, two for dictionary, or something along those lines. We will create an encoding for that. And then if the user selects option one, we will ask for an additional input, which is what is the length of the password. So let's say if our input here is something along the lines of, let's say, test, let's say if this is the password that is supposedly stored in the files, right? Or belongs to that particular user against whom we are trying to perform this cracking operation, right? So in order to simplify the brute force process, for the sake of this tutorial, we would ask the user to give us the length of the password, right? And again, this is not something that is like super mysterious or anything like that. If you check the password policies of a particular company, it is out there, right? In terms of the instructions, when you're creating a new password for a new account, you can just go there and you can look it up and see what the password policies are for an organization, right? So generally, they give you instructions, something along the lines of, hey, that your password has to be minimum 8 length, right? So that gives you at least a starting reference of what that length is. Of course, it is not like a concrete information, which will not vary at all. It can change from user to user depending on what they choose to build their password, but at least you know what the minimum length is, right? So to kind of scaffold from that ideology, for the simplification sake, in this particular instance, we are going to be just requesting the user to tell us how much character length that input password is going to be. So for example, if we give test as an input, then here we would say that 4 is the length of the total characters that is present in the password, right? So that will simplify the computations in the brute force process a little bit, and then we don't have to be staring at the screen for it to finish checking all possible combinations of unknown length of passwords, right? If the user selects the second option, which is the dictionary attack, we will essentially ask for the file path, where the dictionary file that we can use as a reference, which will be a list of the common passwords that are used. This can also be pre-stored in your program if you would like to do that from a program's perspective. But if you want to give the liberty to the users, or whoever the hacker is, that they provide their file path, and depending on the fact that there exists many different variations of such dictionaries that are available on the web, then the users can provide multiple different file inputs, right? So if you want that availability to be present in this implementation, then instead of making the file path where your reference file for the dictionary attack is saved in your system, you make it more dynamic and request them to provide the file path input, something along those lines, right? So that is basically how things will work here. Then we implement the logic of the program using functions, like we have done for all of our previous programs, right? So we will have one functional logic that will implement the brute force attack. We will have one functional logic that will implement the dictionary attack. We also need another function to compute the hash of the input. So that means the user is going to provide, or we said that in storage, in terms of storage, we are going to be storing the plain text password as a hash and not a plain text, right? So we need to be able to simulate that process as well. So we will need one function here that will essentially compute the hash of this input here, and then all the inputs that are present in the dictionary file that will be used for the dictionary attack as well, right? And then the overall output will be, regardless of whichever method of attack is chosen, it will return a true result if the password was guessed correctly. That is, the input matched here and we were able to find it. And it will say it is not found if the input was not found, right? So that is how we will implement it. In terms of prerequisite, we need 2 external libraries here. The first one is going to be the hashlib library. And this hashlib library will essentially help us implement the SHA-256 hashing mechanism. This is a fast hash. This is not a slow hash like the bcrypt one that we learned. Okay, we're just using it for tutorial purposes here. So in order to implement that, we're not going to be computing the hash by ourselves manually. So we will, connect the library hashlib, and then we will use that to compute the SHA-256. We also need a library called iter-tools. We don't have to implement this, it's there. But what this helps us to do is to generate the cross product, right? Or generate the combinations of different characters that we have, right? So for example, let's say, you have a 2-character password. Just to simplify it, let's say you have a 2-character password, and you know that, let's say, again, to simplify the whole process again, the different characters that can be present there is something along the lines of from A to all the way up to Z, and that is it, like just the small letters. And let's say if you have a password that is 2 characters in length, right? So that means you have 1 character here and 1 character here. So the question is, what are all the possible combinations of characters that you can create for a 2-length password where the characters that can be present in each of these blanks ranges from the letters A to Z with the bounds included, right? So that means if I want to generate such a combination, right? So I can say the first one could be AA, the second one could be AB, the third one could be AC, and this can continue all the way up to AC. And then I can continue to, generate these combinations, and I can move on to BA, and then I can move on to BB, and then BC, and then I can continue to do so all the way up till I get to the point of ZZ, right? So generating these combinations efficiently, and now you can expand this idea and say that, okay, if it is 3-length character, you will have something like AAA, then ABA, then ABB, right? ABC, and this will also go on until you have reached to the point where you get to ZZZ, right? And now if you want to complicate this a little bit more, you can say that, okay, it's not just small alphabets, but you can have capital alphabets as well from A to Z, and you can have numerical values from 0 to 9. So now if you bring this all together in order to generate the creation of these different combinations that we spoke of, then we need to have an efficient way in which this can be done rather than writing this whole logic by ourselves. So that is why we are including this itertools library, because the inbuilt methods that are present within this module essentially helps us to generate these combinations very efficiently, right? In a fast way. We don't have to write our logic for that. We can just use the inherent methods that are present in this library that will help us achieve that goal, right? So that is why we want to have this particular library present, okay? Then we also need a dictionary file for the dictionary attack. The file that I am using here in this particular tutorial is the rawq.txt file, which again consists of an updated list of the most commonly used passwords. You can just Google this. So for example, you can Google rawq file GitHub download, right, in Google, and then it will give you the GitHub link where you can download the file. So I have downloaded this file already, and I have included that in my working directory within Visual Studio Code, right? My Project Explorer and stuff like that. So let us go ahead and switch into our VS Code and start implementing this program. Okay, so I have moved on to my Visual Studio Code editor, and what I have done here is basically I have created a new subdirectory inside the cybersecurity fundamentals directory. So all the other programs are here, as you can see from our previous videos. And then within that subdirectory, which I have named as the password cracker tutorial, I have created a Python file, which I'm calling it by the same name as that of the directory name, calling it passwordcracker tutorial.py. And I have also the rawq.txt file present here. So you can see it's present in the root directory, and it consists of all the different commonly used passwords that are being tracked. And there's a lot that is going on in this file, right? So you can check it out, or you can download it from the websites, and this will work just fine, okay? So let us go ahead and first of all include the import for the library. So the first library that we need is the pip install hash lib, right? So this is again to perform the SHA-256 operations. Okay, so I hit an error. Finally, everything did not went smoothly, and let us check what the error is real quick. Print. I did not say anything about print. Okay, so give me a second here. We will I will dive deeper into what this error is and see if I can resolve it before we can start working on this. So I will pause the recording for a second, and then I will check out what's going on, and I will get back to you shortly, hopefully shortly. Okay, so upon further investigation, it seems that the hashlib library is now supposed to be pre-included as an inbuilt library in Python. So hopefully we do not have to install it separately using the pip package manager. So we'll go ahead and give it a try and see if we get any errors or not with respect to just importing the hashlib library. And then if everything goes fine, then that will verify my investigation, so to speak, that the hashlib library is supposed to be an inbuilt library right now with the current updated Python versions, right? So we will just go ahead and import the two libraries that we need, hashlib. Okay, so yeah, it looks like hashlib is already there. So that takes care of a big concern. Every time it's like a mini heart attack whenever you see such a prompt and you have no idea what that prompt is supposed to mean. And the second library that we need is the iter tools library that will create our combinations for the brute force attack more efficiently. So we will just go ahead and import it. So good news, you do not have to install any libraries externally for this one. So I'll just clear my command prompt here. Just start from a fresh slate, okay? And so let us just write down the flow of control that we need. So we need a function that would be able to compute the hashes of our password, right? So this will be done by implementing the SH8256 library. So that is the first node that I need. The second function that we are going to implement is basically perform the brute force attack. Okay, and then the third function that we need to implement is the one that will perform the dictionary table attack, right? And then we need a main function from where the execution of our program will begin. And here, there will be a user input. So I'll just say UI, okay? And the user input will be the password to crack that we want to crack, right? So this is basically simulating the idea that in a realistic environment, this will be stored in some file or database table, right? And then after this, we need to give a menu option to the user. And the menu option would be, let's say, option 1 or option 2. If they select option 1, we will execute the brute force function. All right. And if they select the second menu, if they give input for the second menu, then we will do the dictionary attack. Okay. We also need two more inputs. So that means if menu option, so we have an if-else statement within the main function. So if menu option is 1, then we need to ask for the length of the password. Right, so this will be basically a numerical input as well. User might say 2, 3, 4, 5, 6, 7, 8, etc. Right, and then if the menu option is 2, then we will ask for the file path. So for my situation, I will just specify where this file is present, okay, and what is the name of the file as well to the dictionary. Right, so in our case, it will be something along the lines of look in the folder where this program file is present. So that is represented with a ./, and then the name of the file is rawq.txt. Okay, so this is essentially what the file path is going to look like for our case, right? So remember, every time you specify a file path, it has to start with reference to where your actual program file is present. And then from there, you will have to navigate where the other file is. So for example, if let's say this file was present inside this subfolder, right? So then I would have had to say that get outside of the current directory. So in order to specify that, I would have to say .. So that will take me one step outside of this directory. So now I am inside a directory where I can see all of these different folders. So then I will say go inside, let's say, the password underscore storage folder. Inside of that, so I will give another forward slash. I will write the name of the file where it is present, right? But in our case, this file is present. We have conveniently stored this file somewhere here, somewhere where the program is present. So we don't have to write a very big file path. So here I would say within the same directory where this program file is present, look for a file name, which is this name, which has an extension of .txt, right? So that is about it. So that is it. And then if this will return true or false, right? So true if it was cracked successfully, false if it wasn't cracked successfully. Okay? So that is basically the flow of control for our program, right? So let us follow the same steps that we have always done for all our previous programs. So we will create like a declaration first for our functions, give it a name, create its structure, and then we will step by step fill out the logic one at a time, right? So I will declare all the three non-main functions first. So let us say the function that computes the hash, we call that as hash password. This will take as input the plain text password that will be provided as an input by the user. And then we will give a pass for now because we will figure it out what this is going to be. But this essentially will be a call to the hashlib library. And then the method for SHA-256, which I think is called SHA-256. Okay, but we will check from the examples that are given to us. All right, and let's see the next function. Let's say we call it dictionary crack. Okay, this will take as input the hash. All right, so the hash has to be returned by the computed hash value. So wherever we call it, so I think what we can do is we can make the call to the hash computation in the main file, and then we can provide that input, or we can probably set it up and get it done within the individual functions as well. Okay, but we will figure it out. We will see where this goes. And then we need the dictionary file path itself, right? So we will represent that using a variable that will store the file path inside one of these variables called dictionary file, right? We also need the brute force method. So let's put the brute force method first. So here we have def, and then we will say brute underscore force underscore crack, or crack, right? We wrote crack in the dictionary file. So let us just write crack here as well. And here the inputs will be the computed hash as well as the maximum length of the password. Okay. And we will give a pass here as well. Next, we can move on to our last function, which is going to be the main function. So we have 1, 2, 3. All right. And then we can create the main function here. So we will say if the name of the file that is executed in the terminal is equals to underscore underscore main underscore underscore. And this is basically the definition of the main function. Then we will start writing the logic of our main. Okay, so the logic of our main, let's see what we have. So the user input will provide a password to crack. Then we need to create a menu option, which will provide two menus, which will activate these two functions on line 19 and 22. And then if the first menu option is selected, then we will ask for the length of the password, which will be stored in this thing. And then if 2 is selected, we will provide the file path. The user will provide the file path, which will be saved in another variable. And then we will call these two functions by passing in the two things. So before this, we need to compute the hash. So we will use this function before we call these functions within the main function, such that we can actually compute the hash and then pass the hash value inside of this function in order to do its processing, logic processing, right? So that basically is the idea there, right? So let us say we create a variable, we say hash to crack, something like this, which will store the input from the user. So let's say the prompt that we give is enter the hash to crack in plain text. Okay. Or I think we can do better and we can just say enter the plain text password you want to crack. I think this is better. Okay. Otherwise, it can get confusing that you're asking the user to provide the hash itself. All right. Then we will say the menu, right? So here, let us give some comments here so that we know what we are doing. So you say ask the user for the plain text password to crack. Okay. And this is basically our simulation of password storage in a file or database. Okay. So we want to simplify that process because we don't want to implement it in a file or something like that. Provide menu on how to attack. Okay. So here we will say we want to attack. Did I resume my recording? Okay, hopefully it is recording. All right, so we will print enter 1 for brute force attack. Okay, and we will write the same print statement. So I'll copy this guy, paste it here, and I will say enter 2 for dictionary attack. All right. And then the user has to give us the input and we have to store that input in a variable once the user, is able to enter 1 or 2. So we will say here, the input will be saved in a variable called choice, which will be assigned to the user input, which will say select, quotes, select your option. And then just for reinforcement, we will say 1 or 2. Okay. So that takes care of the input. Now we have to, I think, implement, an if-else statement here. So for the additional inputs, which are specific to either the brute force method or the dictionary attack method. So here what we will do, ask for additional input depending on user choice of attack. Right. So we would say if choice, so that is saved inside our variable, is equals 1, so treat it as a string essentially, then what do we need to do? We need to ask for the total number of character length. So this is basically brute force, right? So length, and we will assign that to the input that will be provided by the user by giving or asking them a prompt that enter the max length of your password input. Now, this will be a numerical input, right? You can see here, once the user provided the input here, I'm comparing that against a string value. So essentially, whatever is provided as input by this input method, you can see here it is stored as a string data type, right? But however, this length value, we don't want to treat it as a string here. We want to treat it as an integer, right? You can see here, since we are assigning that to the input method and the input method stores it as a string, this data type is also becoming string, right? So what we need to do is we need to cast it to a numerical data. So we will wrap this around the inbuilt function to save it as an integer. So now you can see at the very end, it says as int because it takes the string value and puts it as a numerical value, stores it as a numerical value in our program, right? So after this, we are going to, let's say, store the result. Result will be computed, right? And then we will call the brute force attack crack method that we have defined earlier, right? And then here we need to provide as input the plain text input that is given by the user. And we need to provide the max length to simplify the process of the brute force computations. Okay. Now, depending on whether the result is true or false, that is, if a result is returned or not. So what we can do is we can make the function, this function, return the correct guess, or we can return none. None is a reserved keyword. So what we can do then is we can run another if-else statement, and we can say if result. So that means if something is present in the result, right, we will say password, we will give a print prompt to the user in a formatted way. So this F is going to neatly format everything. And we will say password found. All right. And what is the password? We will just print the password itself. This is what the good neat formatting is all about, to include like a string result. Okay. And that's it. And we need an else. So that means if nothing is returned in the result, we will just do a print and we will say password is not found. Password was not found. Sweet. Okay. Now, this is for the first choice, which is for the brute force attack. So we need the second choice now. So I will go back to the if, the original if that we had opened in this control here, that is on line 34, and we will do elif. So we need another comparison to make. So we'll say if choice equals string 2, that is if they are doing dictionary attack, then we will store, first of all, the path of the dictionary file. So we will say dictionary underscore file. So we'll create a variable that will store the user input for where the input is. And here we will input with a prompt. And the prompt is going to be enter the file path of the dictionary you want to use. Okay. And we will save that in this particular variable. And then we will use a similar logic as we did in line 36. So instead of calling the brute force attack, now we will call the dictionary crack, right? And this will also take as input the hash to crack. Okay. And the dictionary file, which is basically the variable that is storing where the user's dictionary is present, right? And then I think we need the same type of structure here. So I'm going to copy everything from here and I will paste that here. So if the result is returned, it is something is there inside the result variable, then we'll print whatever that is. And if nothing is there inside the result variable, we will put nothing, right? So now we need to finish this loop, this if-else branching decision. So it can be either choice 1, choice 2, or none of the 1 or 2 choices, right? So if that is the case, that is, if it is none of 1 or 2, then we don't have to do any comparisons here. We can simply say that print you have entered an invalid choice. That's it. Okay. Okay. I think I'm still missing out on the usage of the computed hash. So I think we should call it here. So I'll create a placeholder here and we will keep this empty for now and say maybe call compute hash here. Okay. I still need to figure this out, right? Because I have not yet visualized this, how we are going to call it inside the functions, or is it going to be from the main function itself and then pass it as an input, because I'm giving the input as hash to crack because I should be comparing hashes, but okay, let's write down the first stuff and the first function and see what we can do, or where the correct logical order will be to call this particular function. Okay, no worries. All right, so we will start with the brute force crack. We already have the hash and we have the input to the max length, right? So now what we need to do is we need to create first the total combination of characters that can be present, which will be used by the brute force in order to create the combinations, right? So this basically is that part where we said what are the possible combinations that each blank of the password character can take, right? So that means, is it A to Z, or does it go numerical values, etc., etc. So we'll store that inside a variable and we'll just call it characters. Okay. And this characters will be the all possible combination of characters that will be considered for the generation of the brute force attack, right? So we will have A, B, C, D, E, F, G, H, I, A, B, C, D, E, F, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So basically, if you don't sing, you don't remember. So anyways, next we have the numerical values. So we will say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? This is easier because you can just look at your keyboard and it's in order, right? But QWERTY keyboard is not in an orderly fashion. So I just didn't want to write that in a haphazard way. We will exclude special characters. We will exclude capital letters just to simplify the process, but you can put it there. It will just increase the possibility checks when IT tools will, generate that, right? So now we do a for loop. So we need to for loop for the total length of the password that we have. So this is what it is simplifying. This is the part which is simply being simplified, right? So we'll create an iterator or a loop control variable. Let's say we call it length. GTH, right? So for length in range, and the range is going to be starting from 1 to whatever the max length is of the password, and plus 1 in order to make sure that since we are starting from 1, we go to max length plus 1 and not max length itself, because that's what would have started from 0 specifically, right? So we need to open this looping process. And now we need to create the groupings, right? So let's say if we want to create the groupings, I think here is where we can generally generate the hash itself. So let's try this. So we create another loop control. So this is what we call as a nested for loop. So that means within a for loop, we have another for loop that is running, right? So if you think about it, let's say if one for loop 1 is supposed to run from 1 to 10, right? 10 times, and then you have a nested for loop. So I'll give a little bit of space, and this is supposed to run 1 to 5. So what will happen is that the outer for loop, we call this as the outer for loop sometimes, and we call this as the inner for loop if we have just 2 for loops in a nested fashion. So what happens is the inner for loop runs 5 times for each iteration of the outer for loop. Okay. So essentially what this means is that if the outer for loop is, let's say in iteration 1, then the inner for loop will run from 1 to 5. And then the outer for loop will go to the second iteration. And then the inner for loop will run from again 1 to 5. And then this process will be repeated. So the total number of executions that you have is basically the total number of iterations in the outer times the total number of iterations in the inner, right? So that means this particular example, it will execute for a total number of looping times of 50, right? So it will repeat for 50 times, okay? If you generalize this, so for example, let's say if you have the total length of the repetitions of the outer for loop is n, and the total length of the repetition of the inner for loop is n, then the generalized worst case time that this will take is basically n times n, which we say n squared, right? So that is the worst possibility of the total time that it will take, right? So that's just to understand like what we are doing here. So what we are doing essentially is that as we grow, right, in the size of the password length, starting from a singular blank. So let's say this is 2 blanks. So the length will be 2 essentially, the first blank and then the second blank. So we want to generate all possible combinations using this guy here, right? And then what we can do inside of this, that then we can compare that, we can compute the hash, and then we can compare that, right? So let's see what we can do here. So we'll create another loop control variable, and this loop control variable will call a inbuilt method which is present in the library for iter2s that we have imported. And then inside of that, there is a method called product. The product expects the list of characters that will be used to create those combinations, right? So we are saying here it could be between, A to Z, and then the numbers 0 to 9, right? And then the repetition, which will basically how many times it has to repeat through the iteration variables, that will be across the length of this particular guy, right? This loop control variable guy, whatever that length is, right? So if it is 1, it will create for one possible combination. If it is 2, it will create for 2 blanks. If it is 3, then it will create for 3 blanks. And what that length is going to be, it will start from the lowest value of the total length of the and go all the way up to the maximum that is there, right? So that is what basically this is doing, okay? And once the guesses are made by creating the combination, we are going to append that to the loop control variable guess. So we are going to open a string, and we are going to hit join. And then we are going to append the previous guess with the next guess, and that will create the things like, AA, AB, AC, ABA, AB, B, ABC, and so on and so forth, right? So this essentially will build that guess. So next, what we need to do is, now that we have created a guess, then we will call the hash password method, which will compute the hash. And then we will pass as an input the guess which was generated. And we will try to compare that to the hash that was passed in. So that means that I should pre-compute the hash and then pass it in here. Okay, and then we are going to, let's finish this statement, and let me just write down what I have in mind after that. So then we are going to, since it's a function, it can return the guess if the guess matches. And if we go through this entirety of this for loop, the outer for loop, if everything is finished and we never enter the if statement that we have written in line 29, then we are just going to return none, right? Which is a reserved keyword that returns it as empty. Okay. Okay. So I'm computing the guess of the password here. Let us finish this computation now. So what do we need to do? This is going to be a simplistic operation. So this is just going to return by calling the hashlib library. Inside of that, I think there is a, SHA-256 method. And then this method, we are going to take the input, which is in plain text. And then we are going to call the encode method, which is a part of this, right? And then after this, we are going to create what we call as the hex digest, right? Which is the presentable format of the hashes, right? Okay, let's see. I have a feeling that I have made a mistake somewhere. Just cannot pinpoint where exactly the mistake is. All right, so we need to compare this with the hash. The hash is coming as an input from the main function. Okay, so here, we are giving the impression that we are calling. All right, let's do this. So let's do hash to crack, and we will reassign this to a call. So we don't have to do the computation. So we can just do hash password. And here we will just say hash to crack. Right, so let's see what I did here. So the user gave me the input in plain text. I stored it inside this variable on line 39. Then I take this variable. Remember, the executions all go from right to left. So you always have to read from right to left as to what is happening. Okay. So I take the variable currently, whatever value that it has from line 39. And then I call the function hash password. It's going to receive that input. It's going to compute the hash using SHA-256, convert that to a hash digest, and then return it back. And then I will store it back to this variable by overwriting the previous plain text content with the return value from this function. So let us remove this thing and put it here. All right. So like this. All right, looks good. Then we ask for the menu. User gives the input. We check what input it is. We ask for max length if it's brute force, and then we take hash to crack, which is having the hash value now, and the max length, and then we go to the brute force crack function. It receives the hash, the max length. We generate the character combinations that could be creating the password. We run two for loops. We first go through the length of the password, and for each field or each blank, we create these combinations that can be created from our prerequisite file. We create how many times we need to repeat this to create the combination. We append that to create our guess. We compute the hash of the guess, compare that to the hash that has been pre-computed in the main function. If it matches, we return it. If we go through the entire for loops and nothing matches, then we just return empty, and we already have the logic of what we are supposed to do if it returns empty. All right, so moving on to the second function, which is the dictionary attack. So let's see what will happen here. So first we have to read the dictionary file. So that's the first step. So we will do the read performance, the read implementation in Python. So with open, and we need to give the file path, which is stored inside this variable. And this has to be opened in read mode. There is no bytes here, so we don't have to do RB as compared to the previous program video that we saw. And we open the iterator, the instance of the file IO operator. And then we do line by line reading. So for line in F, we store it in the word by doing a line strip. All right. So the reason why I am doing this is because this is stored one line at a time. So I'm just going to do line strip. There are other ways you can do depending on the type of file input that you have. So here, everything is one line at a time. So I'm just doing a line strip. So that will store one word at a time here, right? And it will store it here. Anyways, so that is that. And then what we do if, and then we call the hash password. All right. And here we need to compute the word that was grabbed from the file. So we will call our hash password function. And again, we will have the same logic like in brute force. We will compare that to the hash that is provided as an input by the user. And then we will return the word if it matches. And then after this, if the entire file is read, so right here, and nothing is matched, then we will just say return none. Looks good. And don't forget to close the file connection that we have opened here in a more efficient scenario. And let's see, is this it? So if it returns none, we can say password is not found. If it returns whatever the word is, then we can say this is the result. And I have to be careful that when I provide the input to the dictionary, this is essentially what I should be writing. Okay, or essentially I can just write rocku.txt, and by default it is assumed that it will look in the parent directory of the program itself if I do not include this // right? So we will see. If we face any errors, we will figure it out. Let me just take a look at everything, make sure that I have done everything hopefully correctly. The best way to figure that out is to just run the program, I guess, rather than spending more time trying to figure that out. So let's clear this up, and we will say password cracker tutorial. So technically, this should ask me for a password. Okay. Let's say for starter purposes, I just give a plain text password for test. I should have actually given a print statement that prints out the hash. Let me do that before I go any further. So let us stop this, and it will stop it here. Okay. So let me, so that we can all actually, visualize what that hash password will look like. So here we will give the print and we will say F, okay? And we will use the same format that we have here, okay? That the computed hash of the input using SHA 256 is, and then we will say hash to crack. All right. This will just not only just show us what the hash looks like, but it will also, I have some concerns with respect to whether this function is working or not. So I'll just double check that in one singular step as well, right? So save everything. And let's go back to running the program. So we'll have test. Okay, so this is the hex digest of our stuff. This works, and now it requests us to give 1 or 2. So let's do 1 first. Okay, so I'll enter 1, and I need to provide the max length. So I'll just say 4. Better to give some white spaces here so that it doesn't look, like this. All right, and the password was found. The program terminated, so everything went well. Let's try 1 again, and let's see how much delay it takes to, if we increase the length of the password by 1. So let's say we run the same program, we do test 1. This time let's add a numerical value. Hash is inherently different. We still do 1. And it wants me to enter. I will say 5. Taking some time. Good amount of time. We can actually start to notice it as users as well. Okay, you can see, like, just by increasing even a singular character, how much time it is taking compared to how much time it took when we had just 3 characters and then no numerical values were not included, right? This will take a good while. What you can do, okay, there we go. It finally found it, but I don't know, I didn't count how much exactly it took, but less than a minute, I'm guessing, but close to 30 seconds or more, right? What we can do is we can improve this program and run like a time checker. You can Google that. You guys can check that out and try it adventure. Especially for those who are new to Python, you can Google how to keep a track of how much time a program takes to execute and how to implement that code in Python. So you can include that and you can see how much time it takes. But it was considerably noticeable compared to just a 4-letter password, and then compared to that, you just increase that by 1 letter and include a numerical value. But you can play around with these inputs and you can check it out for yourself. So let's try the second way. So we'll run the program again. And again, the other thing that you can do to improve this program, probably, like I showed you in one of the previous programs where we built a menu, and that menu continues to run until the user explicitly chooses to end the program. So you can update this program by implementing that. So that will give you a little bit of more practice as well. So let's run this program again. Let's say test, and this time let's select 2, and let me not mess this input up, not rock test, rocku.txt. Let's see. Okay, so it found. Let's try if test1 is present or not in the dictionary that we have downloaded. And I have not checked the dictionary file, by the way. I have no idea what is there or what is not there. So anyways, so let's see test1. And second option, yeah, this one, you can, make it static in the code itself. So you don't have to enter it again and again when you're running this program for testing purposes. But if you have different file paths, different files that you want to use every time, you can keep it like this, right? Okay, so test1 is also there. If we had participation, maybe I could have asked you for some suggestions. But let's see, what if we do password 1, 2, 3? Of course, I can find this in the dictionary file, but I'm just curious. So rocku.txt. Okay, so that is also quick. I'm not going to run this, but I will leave this up to you guys to run the password 1, 2, 3 in brute force after you have updated this code to count the time that it takes to do it, right? But of course, I have to give you the specifications of my hardware. Otherwise, it wouldn't be fair to, use this video and think that what I am using, that is the same time that will take for you. So I'm using a 32 gig RAM. Okay. So I have some space, and I also have GPU support, and I have NVIDIA, I think 1080, and I might be very grossly wrong here. But as I think the spelling for NVIDIA seems wrong as well for some reason. But yeah, I think I have GPU card, I have a 32 gigabytes RAM, and I think I have, let me just double check instead of just, airballing this right now. Let's see. So we will go to the properties. So what do I have? So I have Intel i7. I have Core i7 with 32 gigs of RAM, 64-bit, of course, but we don't talk about that. And I have like a 3.2 gigahertz processor. Okay. And I need to check how much money, what that NVIDIA thing was. Let me see. I know where to find it, but okay, so go to help. Okay, so it's not 1080, but it's 1050 Ti. So that's what I have. Okay, so that's I'm using. It's not much. It's okay. I think this is NVIDIA, like this. Yeah, I think that is correct as well. Okay, so this is basically my specification, and when I'm running this program, all of the available, memory space it's giving to this program. So even using that, I'm still taking 30 seconds plus, right? So that's a big deal. So yeah, you can check it out. So I hope you like this video. Try it out, implement it, and as always, you will have to document this, explain this code in your own terms after implementing it, and taking a screenshot of a few examples that you try out by yourself, and then submit that on Moodle. Okay, so I will see you all on the next programming video.